In today's global economy, quality matters. Benjamin Franklin once quipped, "The bitterness of poor quality remains long after the sweetness of low price is forgotten." Quality Matters is here to talk about all things quality. So whether you're looking to improve your business, getting ready for an audit, or dealing with failed inspections, tune in, check us out, then get back to doing work that matters.
Well, hello and welcome back to another episode of Quality Matters, brought to you by Texas Quality Assurance, where quality management gets simplified. So I am Kyle Chambers, and today we have another guest on the podcast. This is Robert Mims. He is with the company ThermoTemp, and they handle virtually everything for calibrations, and he can tell you a little bit more about it. But we got to talking here a while back about different ideas around metrology and measurements, and just our own casual conversations were a ton of fun, and I've been dying to get Robert on the podcast. So, Robert, say hello. Welcome to the Quality Matters podcast.
Well, thank you for having me on, for sure. Our conversations have always been a blast, and the calling for it, we're like, hey, can you answer this 5-second question? You know, an hour and a half later, we're like, hey, we actually have to get back to work. But a little bit about me. My name's Robert Mims. I work at a company called ThermoTemp, like Kyle said. I'm a dimensional metrology specialist, which means that I focus very heavily on the length measurement of things. So whether very small or very large, finding interesting and clever ways of making those measurements the most accurately and affordably as possible.
And people probably think about it like, well, measurement, it's easy. It's you know how big it is, right? You just put the caliper on it, you get a tape measure on it. Like, what else is there?
The background of what I do is so much more complex and deep than that, because one of the things I do is I teach a class called Calibration Theory, where we talk about how there's the act of taking a measurement is actually an experiment. You don't actually have and you have to quantify all of these other parts to it in order to actually talk about true accuracy. And there's no such thing as a true measurement, and it's something a lot of people don't talk about, a lot of people don't think about. So the back end of what happens in the back of my mind when I'm telling a customer I think this product will work for you, or this is the right tool for your job, is okay, let's trace it back. How would it get calibrated? How would it get worked on? Where does the traceability of that happen? And all of that.
I don't have near the experience, obviously, in this role that you do, but this is something I've had to run into and deal with a number of times. And I know, if just from my limited scope in this world, the problems I can run into, I can only imagine what it is for some organizations. So we, company I worked for before, we got really tired of keeping up with the annual calibration for the countless numbers of micrometers and gauges and verniers and all sorts of stuff that we had, because we had a lot of welders that used their own personal tools.
Yeah.
And that's a whole other debate. Personal tools, company-owned tools, pros and minuses to it. Whole other topic for another day. So what we came up with is a system for having them do a spot check. And so what we would do is have them check it that morning to make sure it's good. And when I first put this into place, I thought, oh man, this is a snap. This is easy. They just go up, check it. Yeah, it's good. And I found that real quick. It's not that simple.
No. And implementing something like that, like, from the quality side, a lot of what we do in the quality or metrology world is about risk.
Yep.
It's about managing risk, and in the measurement world, we call that risk uncertainty.
Yep.
And it's by implementing this, how am I changing the measurement, the final measurements? How am I continuing to make it traceable? All those things. Yep. So, it's a viable choice.
We've talked about on the podcast before is like, and this is just kind of one of the famous examples in the quality management world. Of course, anyone that doesn't live by Deming and Duran may not have heard about it. Who doesn't? I mean, everyone's got like Deming and Duran in their home library, right? Maybe not. So what he talks about is how Ford Motor Company in the 70s got invited to go tour Toyota's facility.
Yeah.
And so, they go through a whole lot of details in it. It's a fun story. But at the end of it, the Ford executives are looking around the production floor at the final assembly, and they're dumbfounded because there are no rubber mallets. And they're like, where's the rubber mallets? You're just completely dumbfounded because the door, while it fits the car, didn't fit perfectly. And so they would tap, tap, tap on the door until they could get it to fit perfectly so that it closed properly. And they were blown away that Toyota didn't need the rubber mallets to tap it all into place. And what they said is, we design it to fit. Now, that's more of an argument about tolerances and whatnot, but it's a very similar type thing. It's like, how much am I allowed to be off here? Because you're never going to be perfect. I mean, something as simple as temperature variation, or in my case, what I found is guys don't know how to put that caliper on there straight. They think they're putting it on there straight, but they're cockeyed a little bit, and they get a weird measurement.
Yeah.
But,
so when you're, no, 100%. When you start talking about uncertainty, which is essentially what you're talking about, especially measurement, which obviously there's that in manufacturing too, but all that comes back to measurement, and you can go down that train 1,000 miles. But there's so many variables. And when we talk to most companies, if they're not a calibration lab, when I teach, I say, we pick 3. What do you think are going to be your 3 biggest contributors, and test those? And always I say, top 3, you always have to do proficiency testing. How is that guy measuring compared to everyone else?
But that was what I learned the hard way I had to do. So part of the onboarding for all of our new welders was, after they went through my little safety orientation and whatnot, I'd take them out to the shop, and I'd take them to the little spot check area, and I'd have them grab a caliper, and I'd say, all right, I want you to measure that block 10 times. And I just see, can you get it? Can you get the same measurement 10 times in a row?
10 times in a row. No, exactly.
It's a no-brainer, but it's not.
It's not. I just recently was invited out to a company who was applying to do additional work. So they were a very simple machine shop, tape measure, scale, ruler type shop. Who did like gaskets. So big, not super precise, but very big metal gaskets.
Well, even then, when you get to a certain scale, that tolerance becomes such a smaller percentage of the entire thing. Temperature variation is more than that. But again, that goes into what you're talking about with the uncertainty and what's our risk here? Yeah,
but talking to the proficiency testing, they hired me and paid me money to come out and teach them this micrometer and caliper course I developed for them. We now offer it along with a couple of our others on our website, which I've sent you the link to already.
Yeah, and we'll make sure all of that's in the show notes. So just anyone listening, you're like, man, I'd like to learn a little bit more. We're going to have the information in here, and Robert is like the best guy to talk to learn about it. So definitely something to check out.
But the reason I mention that is because I come into this machine shop, and these guys have been machinists for. I mean, they're not young guys. They were older gentlemen for the most part, and
the median age
very
of
bright.
And welders is in their 50s.
Yeah,
which is actually kind of scary. I mean, what happens 10, 20 years from now when we ain't got folks to replace them?
Yeah,
but that's a whole other conversation.
Yeah, that's a totally different conversation. You can have my doom and gloom conversations later.
Yes.
So we have, but I handed them a dial caliper, and most of them didn't even know that there's a printed scale on the caliper. So I don't know if I have one within reach right now, but on every caliper, there's a printed scale. And I was like, this is how you tell what the measurement is. And they were like, oh, that's way simpler than what I thought it was. I was like, okay. And then I was teaching them vernier, and they were having issues. And I was like, it's really fascinating to me. You guys have been doing this a long time. This isn't a negative towards you. You've obviously done your job well, or you wouldn't be working here for 30 plus years. But to me, as a person who studies this specific subject, I don't even use the tools every day. For the most part, what I do is pick up, though this is an older edition, but I got like 7 editions of the Metrology Handbook and different books like this. And
I always love how the handbooks take the whole daggum hand to hold.
Oh, yeah.
It's like twice as big as the Bible.
Well, this is this edition, and this is the previous edition. Hold on.
Yeah.
It's fascinating to me. I picked these up, and people are like, how do you read those? And I was like, are you kidding? You read them in sections.
Yeah.
You go, I have a question. You go read a section of
Yep.
it to get and it reads like a textbook. It's kind of bland and boring, and it's about extrapolating and highlighting and taking notes and all that boring stuff. But I'm currently working right now through uncertainty and pressure testing, which I'm definitely not an expert in. I'm just now getting into like deep into uncertainty.
Yep.
And the more I learn, the more I realize I have no idea what's going on.
I've done a little bit on the back half of that with pulling vacuum for vacuum heat treat furnaces.
Yep.
And even then, it is amazing. You can do the exact same process twice, and you get a different result. You do it 100 times, you get 50 different results.
And how is that? And where is the error inherent in the system? And that's to me, you know, in what I do and how I operate, it's a lot about study and learning. So to me, I'm always digging why.
Yeah.
Let's find out why. And
you and I've talked about this before. You were mentioning veneer. So this is something I had to deal with once before. We had these incredibly large veneers. Like I didn't even know stuff like this was made till we purchased it, right?
Yeah.
And so it went from like 96 inches up to 120 inches. And this was a turbine shop. So we would use this to measure like the difference across some of the compressor blades and things of that nature. And if you don't know anything about power generation turbines, these are enormous pieces of equipment, right? So think about like it's similar to the jet turbine on an airplane, but 10 times as big.
Yep.
Right. And so we had these veneers, and they only have a 1-inch travel on them, right? But they have these massive standards that you check them against. And so we needed to get the standards. You can't see calibrated veneer, but we would have the standards checked, and then we'd have the veneer checked against the standards. And so we sent them off to get calibrated or verified, whatever. I get confused in my own terms here sometimes. And what we decided to do is send off like every other inch increment that we would send out everything at once.
Okay.
And so we sent everything out, and half of them came back bad.
Yep.
And we're scratching our heads like, there's no way half these standards are bad. And what we figured out is the shop that they were in, they were stored in the shop, was really hot. Their van, they did try to do this on a mobile van, and their mobile van is very cold. And these things are so big that 24 hours wasn't enough time for them to normalize. And so just the temperature difference after 24 hours sitting in the air-conditioned environment was still not enough to get an accurate measurement.
Yeah. I mean, one of the fascinating things when you're doing uncertainty measurements, there's a very simple mathematical equation for coefficient of expansion, which is, change in original length times coefficient of expansion times the change in temperature up from 68 degrees. Yep. So difference in temperature between two spaces. And but if you get deeper into the physics of it, you actually get into one that includes time as a variable, which creates a curve that shows the expansion. And it's funny because the 24 and 48, it's like a sigma 1 and a sigma 2. So you're talking like, 68% of the changes happen in one day, and 95% of the changes happen on the second day. And a lot of people are just like, why am I waiting?
Yeah.
I can't see a difference.
Yes. And you can't, but you're not measuring so fine that the human eye can pick it up.
Yeah. Like you're measuring such small.
Oh yeah.
I was a CMM technician for a while.
Yeah.
So I got my start, to give everybody a little history. I got my start in sales. Met a gentleman who brought me in. I was selling Comcast business class, said, do you know anything about calipers? And I went, no, what's a caliper? And he goes, okay, do you know what a micrometer is? And I was like, well, no, what's a micrometer? And he was like, well, I like your spirit. And I was like, okay. He goes, you like learning? I said, yes. And he said, okay, I want you to come sell stuff for me. And got me into dimensional metrology. I worked for him for 4 or 5 years. For me, quite a long time. Yeah. And by the end of it, he was teaching me CMM. He was paying for me to get CMM training and all of this stuff. And
maybe not everyone here knows. So talk about what a CMM is.
Okay, so a CMM is a coordinate measurement machine. So behind me is a 3D printer. Well, one of my many 3D printers. This one's currently a work in progress. I'm rebuilding from the ground up. But if you imagine a 3D printer, which is essentially a robot that moves in 3 axes that you can program, CMM is a 3D printer that measures things. They've been around for decades and decades and decades.
And it just kind of moves around and tracks the coordinates and everything. And then
and it comes in and takes points and then creates a data cloud from that. And then from the data cloud, it can create a 3D
so that's the way you can measure things in 3 dimensions without having to take 10,000 different
automatic.
Yeah.
And automatic. So things like true position are very easy to do on a CMM, where in other formats they are much more difficult to do.
Yeah.
So CMMs
you got involved in working with the CMM there.
Yeah. So I was a technician. I was a calibration technician, a repair technician, and I've done this for a lot of higher end products in my career. But yeah, so after I got out of sales, I went in to be a technician for several years, and really went
opposite track.
Kind of. I'm a nerd, so I picked up, if you can't tell by the Darth Vader painting behind me, I sat down and I was kind of looking at my career, and I was given an opportunity to become a technician. Well, actually, I was told by a company, "We want you to come work for us. What do you want to do?" And they said, "We have an open sales position for you." And I said, "I'd really like to be a technician." And they were like, "Well, what technician experience do you have?" And I went, "I don't."
Yeah.
And they were like, "That's fine. We'll train you." And so from my sales experience, I was able to kind of show that I understood the product, had enough product knowledge, had everything to be worth training as a technician, and kind of worked my way in that field for 3 or 4 years at different companies, and got a huge amount of knowledge that I could never have gotten.
Right.
A huge amount of experience I never could have gotten. But because of that, my brain works in 3 dimensions in very small numbers. Oh, this machine's off by 5 microns. That's unacceptable. And people are like, 5 microns, how big is that? And I'm like, about a third of a human hair. And they're like, I don't think we measure that accurately. What is that in imperial? And I was like, about 100 millionths. And they're like, or no, sorry. Yeah, about it's not a lot. It's a very small number. Yeah. And they're like, we measure in the tenths. And I was like, no, but this machine needs to be right. And so going through and trying to figure out where things are wrong in this, 2 meter by 2 meter machine, to figure out where an air bearing has too much air or something like that that's causing an inherent error, really gave me a love of the math and the deep stuff. And that's kind of where I got just kept diving and diving and diving. So
that's not the same, but kind of similar path with me with quality. Is I was a computer geek. I was happy doing it, and I worked myself out of a job, and they're like, "You want to do safety?" I was like, "Health and safety." I was like, I remember my dad talking about that as a kid. Sure, I think there's something called OSHA. And so when I remember I first started doing my Google search to find out about OSHA, and I tried to spell it like ocean because I didn't realize it was an acronym.
Yeah.
But so that was my starting point. But it was the same thing. It's like the more I get into it, the more I'm like, okay, this makes sense. And I think this is kind of where you and I are on the same page. Is this what I love about quality? Is it's all traceable. Nothing just happens. Like just is a 4-letter word in our home. Like, well, he just hit me. He just this, it just that, it just broke. Nothing just happens. There's an input and there's an output. There's something in between. Let's talk about that in between. Why did that happen? What went wrong?
But I don't want to talk about that. That isn't where I was. What I'm. That doesn't support my story. Sorry, I got kids too. I'm like right there and on point with you.
But I love that traceable process, and it kind of came natural to me, anyways, from the IT world. Like if you've got a bug in a program, it didn't just go wrong, right? I mean, you've got something wrong in the code, one of your variables, one of your inputs. Something isn't right. There's some operation going on. You got the dadgum semicolon when you should have a comma, like whatever it is. And it's the same thought process, just different ways of going about it.
Yeah. So I'm just barely stepping my feet into the quality world. It's funny to me that when I was younger, they were very tied. Yes. Quality and not growing up, but in this
I know
industry
what you mean.
15 years
Yeah.
ago,
Mhm.
because I worked with quality managers,
Right.
and I didn't realize what their job really entailed.
Yep.
And I was a calibration, not technician. I was selling tools for
Mhm.
measuring things. So I
Yep.
thought, oh, those two must go together.
Yeah, and it's the quality guy that buys it 9 times out of 10.
9 times out of 10.
Yeah.
And one of my biggest things I realized is that the quality guy doesn't actually know, isn't taught, isn't shown. He
Nothing.
says, I need it. The guy says, I need a caliper. What caliper should I? Is the cheapest? Okay, that one will work.
Guilty.
Yeah, no, and everyone is. I mean, not everyone can spend their lives focusing on a topic as like there isn't. I'm not going to say there isn't room. Everybody should have more knowledge
Mhm.
about metrology, especially in the manufacturing world.
Mhm.
Especially in the manufacturing world, I would encourage most owners of companies to learn more about it,
Mhm.
just because the quality of product you put out at the end is so affected,
Mhm.
and you know, I've seen companies where between 40 and 60% of the manufacturing time is spent trying to measure something,
Yeah.
and you're paying,
Well, and
man
we used
hours
to
and
do like final inspections. I mean, oh my gosh, we would check because we're the company I came from before. We did a lot of remanufacture on these things, so
yeah,
it's not like we get to make it brand new. Now, once we finally got an EDM in there, we got a little more in the true manufacturing side of things. But up till then, it was let's get our best ag-gum welder and our best machinist on it and see what we can figure out. And
yeah,
so, final inspection, we may take 100 measurements on this thing.
yeah,
And so you talk about opportunity for something to go wrong. And then little things that I found out the hard way is how quickly these metals can wear out. And especially because the alloys and coatings we used, I mean, these coatings are incredibly, incredibly tough.
yeah,
And it'll just wear down your measurement equipment. And so
yeah,
you think you're getting a good number, but that was part of why we put the spot check in place. Because
yeah,
they just wear down the measurement equipment and have no idea. And so
yeah.
suddenly they're 10% off.
Yeah. Yeah, and carbide. I mean, that was the whole reason for the what was it? 5-10 years ago, somebody came in and was like, "We're gonna make every tool with carbide," and it was an added thing. It was like carbide inserts, and don't get me wrong, they've been around for a while, but now you see every manufacturer has a carbide, carbide micrometer, carbide calipers. Because
Well, what would
some of
tick
the
me
stuff we
off
work on.
is the welders, and I see this with some of our clients as well, is welders will love to scribe with a caliper. And I totally get it. You scribe it, you get a good accurate number, but I'm like, once you scribe with that caliper, don't ever use it for an inspection again. It's now scribing. That's its purpose in life.
Yeah.
And I really upset one guy once because these guys would go in debt on the Snap-on truck. I mean, half their paycheck disappears on Snap-on. I'm like, I was like, I will buy a tool if you need it. Like, no, I want my own. Okay, whatever. So he had a lot of really expensive, probably more expensive it ought to be Snap-on equipment. And here he is scribing on all of it. And I'm like, you don't get to use that no more, buddy.
Yeah. Get us simple spring calipers. They make scribing calipers, and people underestimate. I mean, they make a tool for it, and they're not crazy expensive, $50-$60.
Yeah.
And all you do is you set the measurement on a caliper or using a steel rule, and kind of set the exact measurements you want, and then scribe it. And it's cleaner, faster, and you're not damaging your tools. Because one burr, I mean, that's all it takes.
Yeah. It doesn't take much.
10,000th of an inch is a very small thing.
I know. And people get caught up on like, but it's only 10,000. I've only got, I'm only dealing to 100th here. Why does that matter? I'm like, well, if this one instance was the only measurement, maybe it doesn't matter. But, your machinist is taking measurements before he puts it in the machine. The machine has little fixtures and sets that they've got to hold it in place. And those were measured to make sure they're correct. Well, what if each one of these devices is off by the same amount? Like by the time you get to the finished part, it has been indirectly measured 50 times.
Yeah.
So you're compounding error upon error upon error upon error. And all sorts of problems go on.
I would be fascinated to see like what the compound uncertainties would look like on something like a final product something like that, because you're right, you're touching it a lot of times, and how is this, you wouldn't be able to know really what it was unless you made 10 of them and sent them to NIST and spent $10,000 doing the testing, and it went through the whole process. But at the same time, like, there's an amount of, how well do we actually make these parts? And you see like those videos of the two pieces perfectly going together, and
that
I'm like,
so cool.
Every part of me who enjoys measurement is like, that's the goal.
It blows my mind, and it seals. You can't see nothing.
Yeah.
I'm like, how the heck do you do that?
How fine that air layer must be in between them.
Gosh.
Because they come back apart.
Yes. Yes. Because if there wasn't the air between, they would spot weld themselves together.
Yeah, exactly. Immediately when you started to drop it.
Yes. And well, I guess that's something else that a lot of folks don't realize either, is if you truly have a vacuum, two pieces of, molecularly compatible metal touch each other, they will instantly weld to one another.
Yeah.
And so, it blows my mind.
What is the name of that type of welding? Because there's an actual cold joint welding or something like that, where they create a vacuum and push two pieces of like finely ground metal together, and they instantly, yeah. But if it is flat enough and there's no air in between, that metal's just right together. Yeah, on a molecular level.
Yep,
like they were never separated.
Yeah.
And I guess at the end of the day, that's where I get excited, is how do we get to the next stage? When I'm teaching, one of the things I tell people is, when we study calibration, especially, we're studying one of the most important aspects for technology advancement in the world, because if you can't measure it, you can't make it.
No. And things are getting so incredibly small. I mean, like we are, we're butting up on the computer side against the limits of, to quantum mechanics. Like, you can't make circuits smaller than we're making, because the electrons will just freely travel if we get any smaller.
Well, and that's the whole point, is we're getting to a point where we're measuring the size of electrons.
Yeah.
Like, that's exciting. Like, that's a level of deep dive that you just don't. Don't get me wrong. I tell people all the time, if I could get a tour of SpaceX's calibration facility, I don't even like. Don't get me wrong. I want to see the ships, and I want to see all that. But if I could even if all I got was somebody to just walk me through and explain to me like their process, because they're doing some cool stuff over there.
When I left my old company, I was so mad, because like a month after I left, they finally got the approval for a scanning electron microscope.
Oh.
And I told them, like, I just want to come in and play with it for a day. Just let me explore and understand it a little bit. But it's something we've been working on for a couple of years, and it was for some different metallurgical things that they were checking and whatnot, like the metallurgy and what they did. It's fascinating, but it ultimately boiled down to, we've got to take certain measurements, and they're taking it down to the granular structure of the alloys.
Yeah.
But I was so like, oh man, we've been trying for this for years. Y'all get it as soon as I leave.
And it's so funny to me, because metallurgists are like the next step. They're on so much smaller of a level than because I look at whole processes and working through stuff. But I got to tell you this story. And I know this is a quick change of subject. But you will appreciate this, I think, more than most. And I waited to tell you this for this stream.
Okay.
So we were doing some research, because we're, as a calibration company, we get sent stuff that maybe we don't have the data for. So I am often pulled in by our lab manager. He says, "Hey, Robert, can you help me? We don't have a major diameter for this no-go plug."
Okay.
And I was like, okay, cool.
Sure.
Let me just go find the ASME spec. Let me go in and dive into it. I went in, did the math for him, sent it to him, and he goes, "Yeah, that isn't what this is." And I went, "What? Is it just bad?" He goes, "I don't think it's bad. I think that your numbers are wrong." And I was like, that doesn't make sense. Like, I kind of know what I'm doing. I mean, I'm not, I maybe, don't get me wrong, there are a lot smarter people than me in this industry. Then the more I learn, the more I realize I am just scratching the surface. But, so he kept doing research, and I went and saw him the other day, and he goes, "Oh, I figured out that that UNC question. I said, oh yeah, what was it? He goes, apparently every gauge company except for Vermont uses a mil spec, and Vermont uses an ASME spec, and they're off by 0.06 inches. And that people are, exactly the response I had. I was like, you mean half of the people? Because Vermont's a very popular gauge manufacturer. They're not small by any means.
Yeah.
So half the people who trust Vermont, which I trust Vermont, are building their gauge, their equipment, and testing it using this gauge, and half of them are building it and testing it with this gauge and failing stuff that this one would pass, and this one's passing stuff that. And my brain's like, we have, and then I went and looked at the ASME spec, and the ASME spec was, from my understanding, just from the quick look, because I'm not an ASME expert in any way.
Right.
It was written in 1985 and hasn't really had a change. Like, it's still got the 3 punch holes in the order. I was like, well, we need to update these specs because now we're looking at new ways of calibration. People calibrating with CMMs. There's a really cool new machine that ThermoTemp is thinking about getting in, that uses a whole different technology to measure threads, and we're running into issues with like API and all of these other things. And it's been fascinating to me, this what is good metrology, and what is our industry standards. And we're fitting to match the industry standards, and how do we need to do justifications and all this stuff. And
well, we've got one client. They do lots of threading, and blew my mind. The same thread. It's the same thread. It'll work on the same parts. But they've got licenses from multiple different customers for different manufacturing methods to create the exact same thread. And people will request the different license based on a particular application. And that thought had just never crossed my mind. But I mean, I suppose it does. You get different hardnesses, you get different, different ways that the grains of the metal lined up, different wear patterns, different thermal expansions. I'm like,
what are you doing with it?
Yeah,
all this stuff. And at one point in my life, and like, I'm not a manufacturing specialist in any way, but at one point in my life, I did this like really quick deep dive into cold root rolling, which is a way of hardening threads, and I was just like, okay, I'll leave that. I have to just. I'm gonna dive really deep into this if I do it. So I'm just gonna pick it up and put it over here.
Yeah. I gotta say, that is the number one thing I regret since starting my own business. Is it used to be that I had the freedom and the liberty to just zone in for 3 or 4 days on a topic and just totally get lost in it. And that's one thing I cannot do anymore. And that's probably my one big regret about starting a business is I don't have the time to just dive into it for 3 days and then come out of my shell later.
When you go, hey, I wonder what this says, and you just pick up an ASME spec and print it out, and you're just like, I'm just going to spend my evening just reading this caliper spec.
Well, I did that not long ago. We're trying to put some additional cybersecurity features in place for our QMS software. They've got like all these, again, NIST, which I didn't realize this until, not too recently, is NIST, National Institute of Standards and Technology. Like all of the blocks and gauges, and you can probably talk a lot about this, that we use are ultimately generally traceable to some master that NIST has, right?
No, they're all traceable to the SI.
Yes.
I this is one of the many American-centric Americans, me being one of them, are very America-centric. But the National Institute of Standards and Technology is the National Metrology Institute of the United States of America. So if you're in Canada or you're in South America, they're completely different traceabilities. So everything is traceable to the SI, because if you buy a machine from Switzerland, it's traceable to the Swiss NMI, not to the American one. And it's still traceable.
Right.
But you make that distinction for the simple fact that I like to prove that it's a correction I just make to everyone at this point in my life. I'm just like, no, stop. It's traceable to the SI. Then make this quick explanation. Let's just stop there. But yes, everything is traceable. Well, continue.
But yeah, so oh geez, now I lost my train of thought.
We were talking about gauge blocks being calibrated by NIST. Sorry, I interrupted.
Oh my gosh, this never happens, but my train just completely derailed.
You were looking at traceability. Oh, NIST, who you were talking about your CMS software.
Oh, yes. And so I'm looking at it, but they have an entire series of standards for cybersecurity.
Mm-hmm.
And so, my wife, I'm sitting at home and, we just moved out to the country, right? So we got the big front porch and the horses running around out there. And I'm sitting here with a binder, drinking my coffee at 8 o'clock in the morning. She's like, "What are you doing?" I'm like, "Oh, I'm reading cybersecurity standards." She's like, "Why are you doing that?" And I'm like, "Well, we need it, but it's interesting." And I'm just going through and reading it. She's like, "What are you marking?" I'm like, "Well, this is how we already meet this, and this is what we need to do here." And I just sat and read cybersecurity standards.
You were such a quality guy at the end of the day. You're such a quality guy. I picked up during the writing of this class that I'm teaching, I was the intro to calibration theory.
Mm-hmm.
Okay. Which, by the way, let me just give a quick thing on that. Calibration. I teach calibration theory instead of how to calibrate stuff for the simple fact that your processes already tell you how to calibrate stuff.
Yep.
I teach you how to look at those processes, decide if they're working,
any good,
and if you need to change them.
Yep.
So that's why I don't teach calibration. I teach calibration theory. Anyway, but during that, I picked up something called the GUM method.
Mm-hmm.
Have you read that yet? The uncertainty GUM method?
I've heard about it, but I haven't read about it.
It's like a 56-page free online. It exists online. It's done as a free booklet or whatever.
Okay.
And it's about calculating uncertainty.
Okay.
Now, I can sit and read these Ask Me specs all day long. I know exactly what they say. They keep me interested.
Yep.
I nerd out on them.
But how'd they arrive at those numbers?
Yeah. Oh, exactly. But then I'm reading this uncertainty GUM thing, and I fell asleep twice.
Oh, really?
It was the first time I'd ever read a technical document and just went. So some of them are more interesting than others, I guess, is what I'm trying to say.
That's funny. That's funny. I felt bad. We've got a new hire starting today. And so I'm going through all the original, kind of onboarding stuff with her. And I told her, I said, the next couple of weeks is going to feel like drinking from a fire hose. We're going to go through and show you all this type of stuff. I said, but today, and I'm going to apologize in advance, today, I want you to go through and read these standards, 9001, Q1, Q2, so on. Like, just read through them. Just make notes or questions you got, things that don't make sense. I said, and I apologize in advance. Go get some coffee.
Yeah. Might need a pot.
Yeah. Now, I love it, but I also recognize I'm
not for everyone.
Yeah.
Oh, and that's what's beautiful, right? Like, that's why you and I synergize really well. Because I start reading quality documents, and I'm like, what? It takes me a full day to write a procedure to calibrate one thing. Because my brain, I can tell you the math behind it. I can tell you why you want to do it that way. But the like technical step-by-step, how do you do it, is very hard for me to write down in the type of precision that, for example, you found very easy.
Yeah.
You've also been really helpful to me in other ways, like when I was talking about changing procedures. How should you address that? And those things are like immediately in my class. I was just like, these are fantastic. I just need to find somebody like you for uncertainty that just like understands it and wants to nerd out. And...
Yeah. Once I start getting that deep in the math, I kind of just wash my hands of it and move on.
That's where it gets fun for me. Like, and don't get me wrong, I come to this 100%, picking up a book, reading it, learning how to do it. Oh, I don't know how to do this math. Let's look it up. Let's find out what this means. Coming to it completely from I'm fascinated. Let's figure out how to do it.
And that's how I am with the quality side of things. I tell you, I've said this 1,000 times before. It's like, that is my absolute favorite part of this job. I love to just jump into a new business. I may know next to nothing about it, but daggum, by the end of the time we're working together, my goal is to know at least half as much as the owner of the business does about their own business. Like, I just love it. And there's 1,000 ways to solve the same problem, right? No, it's fun. It's a lot of fun. Hey, we are about out of time, so go ahead and tell me a
Okay.
little bit more about this class.
Okay.
You know, how people can sign up for it, and
Okay.
kind of who's the target audience for your class here.
Okay, so the primary class that I teach is Intro to Calibration Theory. It is specifically designed to be accessible to anyone. So owner of a business all the way through inspectors, machinists, if the company wanted to invest that kind of time and money into
So you
it.
don't have to be the engineer or something to do it.
No,
No
and,
Uber geek.
and if come willing to learn is more important at the end of the day in this type of class setting than your job position or your
Sure.
background, because we don't go super deep into math. Like when we cover coefficient of expansion, we literally just say, here's what it is so that you're aware of it. Let me do some math for you so that,
Sure.
or together, so that you get a concept of what these numbers mean.
Yep.
And then let's just back off of it. There's no
Makes
reason
sense.
for you to dive into it.
That could have saved us a few $1,000s with having to get all of these veneers and standards recalibrated.
Correct. And 99% of the time, if you need to do that math, there's software out there that does it for you. Quality software, calibration software that you can have an attached, 2 probes on, and you can do that math very simply.
Yep.
And to me, that is a simpler way to do it. So I'm not trying to say, you come to my class, I'm going to teach you how to ask the right questions, which is the right thing. And I wish I saw more owners of businesses in it, honestly, if I was going to do it. Small machine shops, stuff like that. People looking to build really high quality products, because what you walk away from is first of all, respect for what it takes. But also when you realize that people aren't doing what they're supposed to. Like if you go out to your shop and your machinist is using a caliper and you go pick it up and there's the calibration sticker is bad, a lot of owners who haven't been through the quality side of business go, we just need to get this. Let me just go get a sticker
on it.
Yeah, just get a sticker on it. And they feel like they spend a lot of money on this sticker. They don't understand the why behind it.
You just saved yourself tons of rework a year or two down the road.
Yeah. Or in the worst cases, you have a bad gauge, understanding how gauges go bad, understanding all that stuff. Because if you draw the arcs for how a gauge wears, you can literally pick almost to the day when the gauge is going to go bad. Like almost to the day if you track it properly.
Yeah.
And all of that's covered in. I don't cover it anything deeply because it's a one-day class.
But just get an idea of why did this all of a sudden go bad? It just went bad. It just broke today. No, there was a whole train.
You've been going bad.
Yeah.
And then how to handle in my head, part of what it is also, why do we care if the tool is bad here at the end? A lot of people don't do this, but in theory, every part from the last calibration to the current calibration is in flux now. The customer's using it, it's fine. No, you could. We have the most important job in the world. Things like the Ask Me spec versus the Mill spec scare the hell out of me.
I know. Well, we need to have you back on to talk about that last point, because this is something that we run into frequently in the quality management world. Is if my gauge is bad today, how far back do I have an issue? How do I know how far back I have an issue? What actions do I take?
Yeah,
so
we could do a whole thing on that.
We need to talk about that, because that is a question a lot of people get. And I'll be honest with you, I've not always had the best answers here. So I think this will be a real fun one to explore in more detail. So how many
that might
days?
Require a PowerPoint.
It might. And, hey, we can do that up on here. So while we've got the podcast audio format, I'm doing video now. So we can tell folks, hey, we'll explain what's on the PowerPoint, but you need to go look at the video. It's going to be up on YouTube and Rumble. But so how many days is your course? Are we talking about it's just like a month-long class?
No, 1 day. I'm a big fan of 1 day classes, because when you get into 2 and 3 day classes, don't get me wrong, eventually I hope I have the understanding one day to teach uncertainty to people and teach all of that, which will be multiple day classes. But 1 day is enough where your brain starts to take in a concept, but isn't enough where you're like, I've been the student I sit in the front of the class, I pay attention, but even after 8 hours, you're like, what?
Yep. Yeah.
Somebody
brain dead after a while.
So one day is kind of all, and usually it's the goal is 8 hours, but it depends a lot on, are people asking questions or people being involved. Those sort of things matter. But yeah, it's calibration theory, and then we talk a lot about everything from we start with like the history of the metric system and the imperial system and how everything's traceable, what it's traceable to, all the way through uncertainty and all of the things between. It's kind of a comprehensive, this is what you're really dealing with, and a little bit of the background and reasons behind it.
Now, I smile so much there because our QMS bootcamp training, that's day one of our QMS bootcamp training as well. I actually cover a little bit about the metric system in it. Cover,
you do Egypt?
Like
do you do the ancient Egypt one yet?
No.
So the fact that in ancient Egypt they had a quality system, and the pyramids were built.
I touch a little bit on it. I talk about the pyramids, and I talk about some of how it started out in a craftsman type world, right? And you had the master printers relationship, and how they guarded the stuff. I don't go much more detailed than that.
Well, I can tell you the story later if you want, or I can do it now. But there's a fantastic calibration story in the way that they built the pyramids to 0.02% of total overall accuracy across an entire pyramid, which is incredibly impressive. 3000 BC.
Crap.
Yeah, and it had to do with. Yeah, we'll do it later.
We got to do it later. I got to wrap up. But again, this is why I say, kind of like you opened with, we start talking, and it's an hour and a half later, like. We need to get back to other stuff, I think. So go ahead and grab another time slot.
Okay,
and
I will. Yeah, for sure.
We'll talk about calibrations and, what happens if you got a bad one. And we'll discuss Egypt a little bit more.
Sounds good.
But,
Sounds good.
Man, it's awesome having you on here. So if folks want to find out more about the class, again, we're going to have that in the show notes, their website they can go to.
Yeah, I've sent you the link. ThermoTemp.com has it. It's under, there's a big banner that says Metrology. We have a couple courses up and more to come, hopefully.
Make sure it's all there. So awesome, man. Thank you so much for your time. You have a great day.
You too, my friend. Have a blessed day.
Thank you. All right, folks. Well, that's it. We are probably going a little bit longer on this one than I like to, but we're having a lot of fun with this longer format on the podcast. I hope you enjoy it. If you have not already, please make sure you click the like, subscribe button wherever you're listening or watching. We're on iTunes, Spotify, Audible, YouTube, Rumble, and tons of others I can't even remember now. So be sure to like, subscribe. We want to hear from you. So if you got a certain request or anything that you'd love to have us talk about, be sure to leave a comment or leave us a review. But I hope you guys have a great day. And remember that quality matters.